Math 8, volume of cones, extra examples. These first three examples are just finding the volume, just low-level repetitive examples. On them, remember first step, you want to write the formula. Volume is 1/3 pi r squared h. In this case, r equals 2 and h equals 4. So the volume is 1/3 pi times 2 squared times 4. And that calculates out to be, let's see, 1/3 pi 2 squared times 4. That gives us a volume of 16.75. I'm going to round that to 16.8 because it says round to the nearest tenth. And that will be in inches cubed. Okay, next example. Again, since it's a cone, the volume formula you should write down V equals 1/3 pi r squared h. V equals, actually, we need to identify some things here. The radius is going to be 3 and the height is going to be 3. Now, the reason the radius is 3, the diameter is 6, and that needs to cut in half to make 3. Because that'd be 6 all the way across and 3 halfway across. So this is V equals 1/3 pi 3 squared times 3. And that would be 28.27, that rounds to 28.3 meters cubed. Okay, number 6. Since it is a cone, we start with the cone formula, 1/3 pi r squared h. We're going to identify that r is 5, h is 10. Then we plug in v is 1/3 pi 5 squared times 10. Typing that into my calculator, 1/3 pi 5 squared times 10. And that gives me 261.8. It goes 799, but we're going to round it to 8. Millimeters cubed, or cubic millimeters. Okay? All right, now I've got a couple of multi-step problems. You must answer a trivia question before the sand in the timer falls to the bottom. The sand falls at a rate of 50 cubic millimeters per second. How much time do you have to answer the question? Okay, in this multi-step problem, the difficult part of these problems is planning things out. If we want to know how long it will take for all of this sand to trickle down into the bottom, we need to know how much sand we're starting out with. The amount of sand we start with is the volume. So we're going to need to find the volume of the sand. Once we find the volume of the sand, we need to find out how much time. And to find out how much time, we are going to have to use the unit rate they gave us of 50 cubic millimeters. 50 cubic millimeters per second is going to become part of that. So first step, find the volume of the solid. Since it is conical in shape, it's 1/3 pi r squared h. We're going to identify r to be, just as it says here, 10 millimeters, and h to be 24 millimeters. This gives a volume of 1/3 pi 10 squared times 24. Okay, typing all that in, 1/3 pi 10 squared times 24. And that is 2,513.27. Let's see, what does it round to? It doesn't ask me tell me what to round to. I'm going to go a couple decimal places for now. I'm not at the end of the question right now anyway. But it comes out 2,513.27 cubic millimeters. And that was the first thing I had to do, find the volume of sand. Now I know that. Now we're going to figure out how much time. And for this, you'll use your proportional reasoning skills. Now, if you automatically can figure out whether to multiply or divide by the number 50, you go ahead and do that. Through experience, you would know. If you are unsure, you can always do a proportion. It is 50 cubic millimeters per 1 second. And it's going to be 2,513.27 cubic millimeters for an unknown x number of seconds. And with the cubic millimeters on top and the seconds on bottom, everything's lined up. So this proportion takes care of figuring out whether you have things lined up correctly, whether to multiply or divide for you. As I cross multiply here, I get 2,513.27 equals 50x. It looks like if you had decided you should divide by the 50, you were correct. Anyway, if I divide on my calculator here by 50, it takes 50.26. I'm going to call that 50.3. So the answer here is 50.3 seconds. Not quite a minute, but getting pretty close. So definitely not an hourglass. An hourglass generally goes for 3,600 seconds or 60 minutes. Okay, another multi-step problem. A machine part is in the shape of a cone with a height of 13.78 centimeters and a diameter of 9.34 centimeters. The part is made out of a still with a density of 8.03 grams per cubic centimeter. What is the mass of the part? All right, multi-step problem here. We do have a density given, and we've got dimensions given. So we do want to, of course, find the volume. And then after finding the volume, we're going to use the density to find mass. And we'll do that using proportions, pretty much the same way we did on the previous problem. Let's start with finding the volume. Because it does tell us that it is a cone, we're going to use the volume formula for a cone. We're going to identify the radius. If I look back up in here, it does tell me it's a diameter of 9.34. So I need to take 9.34 and divide it by 2 to get my radius of 4.67 centimeters. The height is going to be 13.87 centimeters. Okay, that gives me a volume of 1/3 pi 4.67 squared times 13.87. Okay, the numbers do have some more decimal places in them, so they do take a little longer to type into the calculator. The calculator doesn't really care about the time it takes to calculate. Whoops, I pressed something wrong. Let me fix my calculator here. I get 316.766. I'm just going to go 77 for now, and that is in cubic centimeters. Okay, next, I'm going to use the density to find the mass. Now the density is 8.03 grams per cubic centimeter, and that's going to be the same thing as 316.77 cubic centimeters, and since it's the same type of still, we're going to have x grams. And when we solve this, we will find out how much the piece of steel weighs, how much the part weighs. Now, if your proportional reasoning skills allowed you to know to multiply already, you wouldn't need to draw this cross product, this proportion. But if you were unsure, it doesn't take long to go ahead and do it. And if it increases your chances of being able to get the problem correct, it's worth the few seconds it takes. Anyway, the cross product here gives me 2543.66. So this would weigh a little bit over 2.5 kilograms. Let me round it to the nearest gram. That would be a 4 grams, or 2.544 kilograms if you were asked to put it in kilograms. Thank you for watching.